Today I'll be talking about the iPhone, iOS security, and jailbreaking. But before we do that, let's introduce myself. So I'm Jethro. I was originally born in Jakarta in Indonesia, and like 18, 19 years ago, I moved to Amsterdam in the Netherlands. That's me over there, right, in the Amazon picking challenge. And this picture here, you can see Amsterdam, which is very beautiful in my opinion. And last year I moved to Tokyo. So before that, let's have a bit more detail on what is happening here, right? Many of you have probably or might or not seen some articles in the news regarding the Amazon picking challenge and Team Delft. However, this was one of the most common pictures that you could see on the internet of one of my team members and the robot in action. So you might all wonder, like, where am I? Where in this picture am I? Well, the answer is behind this plank here. So there. That's why nobody could see me back then. And also, the Amazon picking challenge was also where I met Preferred Networks and became acquaintance with. And this was in a very peculiar way because this is what I have seen in Preferred Networks. And for the viewers out there, we are still hiring on the internet. Unfortunately, or fortunately, I saw this poster, right? But I did not see it for myself. It was actually one of my friends who pointed me to this picture because I was busy spying on Team MIT here from this side. And as you all see, this is where PFN is, and this person from Nikkei Robotics. So the poster was on the other side of this whole alley. So it's a good thing I still saw it in the end. Right, so that's about the APC. My educational background and career so far was mostly from the Delft University of Technology, where I both graduated for my Bachelor of Science and Master of Science, and immediately afterwards became a researcher in the robotics department. And well, since you all know, since September last year, I'm a researcher at PFN. As for my interests and hobbies, I do have a few hobbies and interests. I like cooking, mostly Western dishes, because there are many good Japanese restaurants and it's quite hard to make Asian dishes altogether, in my opinion. I also like playing games, mostly Japanese RPG games, and I have been playing Final Fantasy XIV a lot during my student time. But right now, you don't really have much time when you're working so hard. I also like the music coming from those RPGs, but also classical music, and but mostly because I also play the piano. And one of the most important things, in my opinion, about my hobbies is that manga and anime, it plays a big part, or it played a big part of my life, and that's kind of how I ended up here. So for those who were wondering, I really like Adachi Mitsuru and Code Geass, right? That's, yeah. So far my hobbies and interests and my self-introduction. So without further ado, let's move on to the real talk. Right. I'm wondering how many of you still know this picture. You might find it unbelievable, but this is already 10 years back in 2007 when back the late CAO Steve Jobs of Apple introduced the first iPhone. It was pretty revolutionary because it had its own operating system, unlike all the Java phones back then. And it had a quite decent ARM processor and also much more memory than all the other phones back then. And unfortunately, it was carrier locked to AT&T in the United States. But that didn't stop anybody from buying it. Now, the most interesting thing is that this release date here on June 29, 1 month later, we had this person called GeoHot, who was back then still 17 years old. He actually career unlocked the iPhone using a hardware-based method. And of course, this shocked a majority of the world. And a Certicell founder found it so impressive that he traded a Nissan car and 3 more iPhones for this unlocked iPhone. Luckily for everybody else, a software unlock method was released by an anonymous group later in that year. So fast forward 10 years later, and we now have the iPhone 7 and iPhone 7 Plus, which runs iOS 10. And you can find it everywhere in the world. And the computational power and memory capabilities are much better, and it's quite shocking how it evolved from 128 megabytes of memory to 2 or 3 gigs, depending on which model you have. The interesting is, between the first iPhone operating system and iOS 10, there has been many changes inside the operating system, which not all of you know. And this is the most secret part, or I would like to say secret part, of iOS, because all the general public knows, and maybe computer scientists know about iOS, is that it is closed source. It runs a Darwin core or kernel, which is a derivation from the BSD kernel, and some other projects called the Mach-O kernel. It does run a HFS plus file system like on the OS X. And we all know that the iOS versions that you can install on your iPhone are controlled by Apple. So this picture depicts it. If you are trying to restore an iOS version that is not supported at this current time, then you will probably get this error in iTunes. So here's a brief timeline. I did not include it all the way to right now, but from iOS 1 to iOS 6, most of this iOS security was already being developed and established during this period, with iOS 1 not having any security at all, and iOS 6 having a pretty tight security. All this security evolved all the way also through exploitations of the jailbreak scene. So I would like to talk more now about the security. And so what is jailbreaking? Jailbreaking is the act of breaking out of its ch root or jail in a Unix operating system, according to Wikipedia. And it will allow you to run unsigned code on your device, which is a pretty important incentive for people to jailbreak their phones. And some people might also think jailbreaking makes yourself feel like the real owner of your device. Because if you have bought an iPhone or just any device at all, but if somebody else is controlling what is allowed and what is not on your device, do you still feel like you are the owner? There has been many suit cases about this, but it is legally allowed by the law. But Apple might void your warranty for it, to return and reparations. So what many people do not know is that jailbreaking relies on kernel exploits for vulnerabilities, and its side effect is it also compromises the device security against potential malicious attacks. And I made this part bold because this is a really important part. So you all have to know that it relies on kernel exploit, like the core operating system. And there has been many levels of jailbreaks, a tethered jailbreak, a semi-tethered, and an untethered jailbreak. Each of these reflects the potency of the exploit used for the jailbreak. As you can see here, a tethered jailbreak requires you to connect your device or have your device connected while rebooting. Normally, this is not a big problem, as most of us do not turn off their phone at all right now. It will just be on standby mode. But it is possible that in dire situations, you have your phone turned off, and when you turn it on, you are not able to boot it again into a normal state. So that's why untethering or a really potent exploit is needed to allow this. So before we go into any further of the details in the iOS security, I would like to show you the boot chain of the iPhone and generally all iOS running devices. So right here, you can see the boot ROM. And the boot ROM is the lowest level of hardware. This is actually in ROM, right? So read-only memory. So it will also decide whether you want to boot normally into the normal boot process or go to a DFU mode. I will talk more about the DFU mode later. And basically, if you can find an exploit in the boot ROM, then Apple cannot fix this or cannot close this gap unless they release a new version of the boot ROM in a later device. So this is really in their chip. And the interesting thing is also the iPhone 3GS is actually full of a boot ROM exploit. So it could be hacked and jailbroken during its lifetime. And yeah, they later patched this boot ROM so that it was not possible anymore. So the DFU mode. What is the DFU mode? For a lot of you who bought the iPhone at first, you will see this symbol, this screen on the left side. This indicates that it is actually in recovery mode, because it will then say, please connect it to iTunes to restore your firmware. So back here, it will take the upper part, right, to restore the firmware. However, the DFU mode, the device firmware update, is much stronger in such a way that even if this path is broken and the kernel is damaged or corrupted by the memory, it can still update or reflash the firmware to correct it and repair it. However, this is much harder to enter. So here I have images to show the sequence of how to enter DFU mode and recovery mode. As you can see, recovery mode is pretty easy by just pushing your power button and the home button for an extended period of time, and it will automatically go to the recovery mode. However, the DFU mode requires a lot of timing and precision of how many seconds you are pushing this. So you need to hold your home button and power button for 5 seconds, release your power, or no, keep holding it until it turns black, release the power button, and keep the home button pressed for 10 seconds. So it's actually really hard. I have experience in doing this several times, but yeah, it can be pretty bad for your heart if it doesn't do what you want, because you might think that, oh no, my device is broken. So the basics of iOS security, or all the features of iOS security, are listed here in this slide. I will go through each of them bit by bit, and this picture on the right side will depicts on what is actually happening, right? So you have this boot ROM that is controlled by Apple, and once you go to a higher level, you get into your application and your user. And the kernel is where a lot of this security is in place. So let's go each one of them to get a better feeling of what is going on here in iOS. So a reduced attack surface is a technique to, the goal of this is to minimize the amount of code that an attacker can access or target in your operating system. iOS has done so from the very beginning by not providing support for example, Flash and Java, because these were two platforms that were known to be very buggy, and it had lots of exploits and vulnerabilities. And by also selectively allowing which file formats are supported on your device, for example, PDF readers or PDF features, you can also control the access and vulnerability list. So if there is a vulnerability on like a very advanced feature, but iOS does not have this feature, then you still cannot attack it. That's the idea of reduced attack surface. It also features a stripped down operating system. As many of you know, there are like core commands on Unix that are necessary to be useful, you know, like deleting a file, getting a list of a file, or seeing the processes in your operating system. By not providing useful binaries, an attacker must bring their own tools, so to say, to do things they want. So you cannot spawn a shell and do whatever you want if you are attacking iOS. Also, it has privilege separation, like most Unix operating systems, right? So most applications or processes run as mobile users, which had limited privileges, and only the important processes run as root and is entitled to do much more powerful and important things. And a really big security feature and a really important one is the mandatory code signing. This is also what kind of makes it different from Android, right? As you all know, on Android OS, you can all just sideload an app by allowing it to run on your device. However, in iOS, you cannot just load some random binary from the internet because you want to. Apple enforces this mandatory code signing so that whatever application should be run on iOS first have to go to control, which is the App Store. So to do so, it will be signed with a valid and trusted signature, and all processes that can be executed must have this valid and trusted signature. Luckily, this also has the role of some kind of antivirus. So I don't know if you guys know the stories of Android and viruses, because there seems to be a lot of antivirus software for Android and anti-malware, but while it is there on the App Store for iOS, it is not really useful because, well, there is mandatory code signing. And another part of this process of security is that in the memory, the stack and the heap are marked as not executable, which means wherever the data is stored, you cannot execute that part of the memory. So you can either write to a certain memory for data or execute, but not both. This way, or iOS prevents code injection attacks. So I would like to take a slight intermezzo to see, to explain you what this actually means. So let's have this very simple program with a main and a function called foo. And foo, this function foo, accepts an array of characters that is then string copied to a buffer to C, right? And so the main accepts the arguments here, and how it looks like in the memory is like this. So if you compare this, the code from this slide, let's say we have the argument hello, then the buffer will contain hello here, no problem at all. But what is the crucial part is that there is no check around this area of string copy, which means that we can also put a character array that is longer than just 12. So, for example, we can craft the argument in such a way that it fills not only your buffer that you have assigned to, but it will also override the saved frame pointer and the return address. So this is called a stack buffer overflow, because suppose I am an attacker and I have the buffer with some kind of code that I want to run, and I know exactly where, on which address this memory page starts, then I can craft my argument in such a way that whatever it overwrites this return address points towards the address of the memory page. And this way, the return address will jump to my data storage and run my code that I injected. So that is the core concept of the stack buffer overflow. And if you all listened to me for the few slides ago, you will immediately notice that, hey, we cannot do this on iOS because it has code execution prevention. And also, all codes need to be signed in order to be executed. So the evolved version of this stack buffered overflow is something that is known in the vulnerability and exploit world as return-oriented programming. So suppose we still have this main function with a character array and a buffer. Instead of injecting the code now in your buffer, instead, because that might not be permitted by this operating system, we can instead try to call a function in our program that is not called. So we know that you cannot inject arbitrary code, but this way we already came up with the tool in our own program, and we can call this function by first signing this code, uploading it to the operating system, and then exploit this vulnerable function to call the function that is originally not called, and then, for example, call a shell to do whatever we want. So the next step of this is instead of spawning the bash shell, we know that, for example, there is a function that is not called but calls a different kind of command. So instead of the bin date, we do not want to spawn this, but we want to spawn our shell, which is in this character array. So the goal is then to chain or make a payload in such a way that we first exploit this vulnerable function, call this function that is not called, and override its arguments in such a way that this character is used instead of the hard-coded string here. Even more advanced is to chaining several functions that is available called gadgets. So if we know the location of gadgets, we can chain the functions in such a way that it will be beneficial to attack the operating system. So right here, the goal is to, again, start exploiting the vulnerable function. Then we want to add bins to call this function, call sh, this add sh, so we have /bin/sh, and then we call this function. So it requires chaining of functions or gadgets to do what we want. So like I said, this data execution prevention and code signing combined will allow us to only, or allow an attacker to only attack using its return-oriented only program. So it is very hard to create a return-oriented program that bypasses all this, but it has been done, and I will talk about such a jailbreak later. Starting from iOS 4.3, iOS also included one of the most more modern security functionalities that is now also found in Linux, and it's called address space layout randomization. As you remember from several slides ago, for an attacker to call programs, he must also know the memory address of what he is going to call. So if address space layout randomization, ASLR, counter attacks this by randomizing the memory space between each boot. So if you are booting up, then your memory address is shuffled in such a way that you first need to guess where each of your data is. And later in iOS 6, they extended this ASLR to also shuffle the kernel memory. So with this in place, attackers need not only one, but two vulnerabilities to exploit using their return-oriented program. So one exploit for the code execution, but also one to leak or recalculate the memory address they want to execute. With ASLR, Apple also included a technology called dynamic code signing. This is needed to increase the performance in their JavaScript engine, because if you can compile it during runtime, then you just can have much nicer programs, and heavy web applications can take full advantage of the underlying hardware rather than being limited to the operating system. It did so by allowing Safari to have one single page of 32 megabytes that is both readable, writable, and executable, which completely bypasses this data execution prevention, as we know. However, in iOS 10, it has been hardened again in such a way that this read, write, and execute page is now virtualized into a read and execute and a read and write page. And by keeping this read and write, the writable page secret, it prevents exploitation of this virtual page. So the last line of defense of iOS security is the application sandboxing. So even if an attacker managed to get through all that security and break into privileges, the application is still restricted to a certain sandbox. So it can still not access any data beyond the application sandbox. So this is also why we have menus in iOS calling open in whatever application. But once you hit that open in whatever application, it does not move this file to the next application. It will make a copy of that file. So be careful if doing this for big data files, such as movies that you open via Safari, but you want to open it in some other customized video player. And another thing is, I told in the beginning that jailbreaking compromises device security in such a way that it also compromises the data on your device, because, well, you are making use of an exploit, so it kind of makes sense that your data that is inside your device is also compromised. However, with the Apple A7 CPU that is found, I think, on iPhone 5S, Apple has separated this process of data encryption from the kernel, so it runs separate from the main CPU, in such a way that it is only responsible for your fingerprint data storage and data encryption. The secondary function of this secure enclave processor is that it also adds artificial delays to passcode brute forcing. This is why the American government had such a hard time brute forcing the San Bernardino hacker iPhone, terrorist iPhone. So starting with iOS 9, they further increased the security of iOS by also checking and checksumming in the kernel. By doing this, something else that is not the kernel will constantly check for the data if it matches the checksum that it should be in. So if you are trying to write into these fields when a checksum is happening, the kernel will panic and reboot your device, triggering the ASLR again and making the device safe. However, to not kill a battery, it is triggered only randomly when the device is not busy, because you can all imagine that doing this continuously might drain a lot of battery. So I would like to go now into a short selection of attacks in iOS. And one of the first exploits that has been used in iOS is a libtiff exploit. Because when people discovered which version of libtiff was used in iOS, in iOS 1 or 2 or something, they immediately knew, this library is actually vulnerable to attacks. So they made use of that and attacked iOS that way. It's also noticeable that iOS during that time did not have many security features. So it did not have data execution prevention. It did not have code signing. And throughout these kind of attacks, it made Apple realize, oh, we need to fix this and add this security feature. LimeRain is very noticeable for its, because this was, I think, one of the most first boot ROM exploit. So once this jailbreak was released, the attackers basically told Apple, well, we found an exploit in your boot ROM, and with this we can forever jailbreak devices all the way until this version. So everything that ran an Apple A4 was jailbreakable forever. Also, the pinnacle of the jailbreak scenes, public jailbreak releases, was Jailbreak Me 3, right? So if you went to jailbreakme.com, you would find this screen here, which had this button into it, and behind the scenes was that it made use of a font integer overflow. So the author of this exploit was very well versed in finding exploits, but also kernel exploitation in iOS. And even the Apple security employees were very surprised such an exploit exists, because what is so special for this jailbreakme.com version 3 is that Apple had already implemented ASLR. So it used a very strong exploit to bypass all of the security features. So that's it for the exploits. Many of you might wonder, how did people actually find these exploits or debug and make their way through the kernel if Apple's operating system is closed source, right? So the answer is, or part of it was made possible by the iPhone dock connector. The iPhone dock connector is, as we all know, just a tool to charge our phones and transfer data between our phones and our computer. But if that were the case, then why does an iPhone dock connector cable have 30 pins? Well, the answer to that is that each of these pins are very special, because it can actually, it has line in and line out for audio as well as video. But the most important thing here is pin 12 and pin 13, which enabled serial connection. So once people made their own breakout board to connect the serial, you could SSH into the device and set whatever boot flag you are using to boot and get access to the kernel. So in the end, we are seeing less and less jailbreaks nowadays. And I was also wondering what happened to jailbreaks, and why is it that it is now less common for jailbreaks to be publicly released. One of the reasons is that long ago, when the jailbreak scene was very active, all the exploits were held and attacked or exploited, I have to say, by Western attackers. And these people shared exploits between each other, and they did it for the benefit of the community in general. However, once the device security has become more tighter and tighter, the community also has become more greedy, as they were kind of spoiled in the beginning, saying, where is the jailbreak? And you suck. Why is there no jailbreak anymore? So in recent years, the jailbreak scene moved to Chinese hackers instead, where instead of sharing the exploit with each other, they keep it for themselves. And the thing is, some of these Chinese hackers also get paid for some kind of big company that would like to have an alternative app store to the iPhone to install Chinese-only applications. Also, as there is reduced benefits of jailbreaking nowadays, now that these features increase in your device, because like I said, the first incentive to jailbreak was to run unsigned code. But for unsigned code, we mean like applications that you would like to see and have on your device. So by making this and releasing this legally, it might be possible for some to say, well, I don't need my jailbreak anymore because there is already an application that can do this. And also, bounty programs have been started for finding exploits, which is also a really good incentive to hand in the exploit to the official people rather than releasing it in public for the benefit of whoever finds this exploit. To give you an impression of these bounty programs, Zerodium offers up to 1.5 million US dollars for a 0-day exploit. So this is actually pretty insane if you realize that solving a millennium problem like P is NP will only net you 1 million US dollars. And the FBI also paid $1 million to unlock the phone of the terrorist from last year. So compared to these, you might find the Apple security bounty program to be a bit lackluster, so to say. But it is a good thing that it is there. So with this, I would like to conclude my presentation. I've told you that jailbreaks have made iOS more secure over the time. And this also causes jailbreaks to be increasingly harder to produce. And before jailbreaking, you should all think twice, because every unfixed exploit and jailbreak can be used as a government backdoor. So be careful, guys. And last, bounties is a good incentive and might discourage public jailbreak releases. So if you like this talk, then I would really recommend you reading this book, which had a lot of information I took for this presentation, and also make sure to visit the iPhone wiki. Thank you for your attention.
So if you sell your exploit for $1,500,000 to Zerodium, what do they do with the exploit?
They stock it up, and they will probably sell it again to maybe NSA, FBI. Or they might set up some kind of backdoor that nobody knows of, right? Yeah.
So you talked about the code signing. Do you
Yes.
know if the device has a online revocation list checking?
Yes, it does. So supplementary signatures can be provided to app developers. So if you enroll for the app developer program, you will get your own personalized signature to sign applications and load it into your app. This is how iOS developers test their application. But if they find you abusing that signature, they can revoke this signature. And
Okay, and the revocation checking is done when you run your app in your device.
Yes, when you run your app.
Every time the device asks the
Yes.
revocation server.
Yes,
Okay.
yes. I think that's. Any more questions?
So in the user PC, audience PC, we use virus check programs. So in the case of the iOS, is there some program that constantly examine the program or data in the iPhone?
Not constantly, but rather at launch. So before you launch your application, you need to specify, or it is done internally, right, by a process called launch CTL, if I remember. And that application icon will actually spawn this launch control with given arguments. And then it will tell you, yes, you are allowed to run this program, or no, you are not allowed to.
Related to that, so suppose you are an app developer and your app has some confidential information, and you want to make sure that your app is running in an unjailbreaked broken device.
Yes.
Is it the way to check that the device is clean and safe?
Yes. In recent applications have countermeasures for this. What I found mostly is, so even stuff like Pokemon Go, or what's it called? TV streaming apps. There are several ways. So one of the ways is simply check whether .bin.sh is installed, because whenever you jailbreak, it will always install /bin/sh. So if this is the case, then you can deny access to the application. It's one of the ways. I'm pretty sure there are many, many other ways, but yeah.
So,
all right.